Hi, and welcome to ASFT Booth 508. This short video will detail the SBIR Phase 2 Topic N07065 Multi-Level Security Smart Proxy Agent for Bandwidth and Time-Constrained Users, or as we call it, the Communications Prioritization Tool, the CPT. To effectively communicate with other platforms, ballistic missile submarines must optimize the use of available communications bandwidth. Currently, submarine radio operators must make decisions about how to optimize the communication paths available to the submarine based on prior experience alone. Many times, such mission-critical decisions must be made in stressful situations. Prior to the CPT, message information was stored and handled in separate communication enclaves governed by the existing Information Screening and Delivery System, ISDS, developed by SPAWAR. Our CPT takes all message queues from each of the enclaves and prioritizes the messages based on approved Navy protocol OPNAV 5510.1. When transmission is initiated, all higher priority messages will be transmitted regardless of the originating enclave. To prioritize messages, the CPT considers multiple factors including enclave IP and port, naval message speed of service, message classification, and the message serial number. An overall priority score is calculated based on this scheme, and messages are reordered accordingly for transmission. In our scheme, there are 3 major and 1 minor grouping. Priority scores are added with the main category receiving 100s values, the next major group receiving 10s values, and the third major level receiving 1s values. The tiebreaker in our case is the serial number. This level is given decimal values, and when added, in total score ranging between 111.001.0001 to 455.367.9999. As a result, the CPT aids to minimize transmission times, handles all classified enclaves, and minimizes disruption to the current system performance. The CPT software written in Microsoft Visual Basic.net is an embedded smart proxy application that is integrated between ISDS clients and their complement ISDS Shore Communication Servers, or the Broadcast Control Authority, the BCA. The CPT is predicated on the TCP/IP network protocol and uses asynchronous socket technologies to capture its data in need of prioritization. Therefore, CPT has the ability to be inserted into any TCP/IP-based system, provided that the prioritization rules are defined and any special or proprietary data segment formats or conversation elements are defined. In this SBIR, the CPT prototype is integrated with the CSRR to capture all ISDS enclave messages, prioritize them, and complete the transmission to the Broadcast Control Authority shore site. During development of the CPT, Wireshark was used to capture TCP/IP data streams from the ISDS client to the ISD shore servers. During our analysis, 4 groupings were found. The aqua colors note the Navy message body. The yellow and gray correspond to proprietary ISDS client headers and footers and proprietary ISDS shore comm server responses. The green section is an ISDS message summary. In order to adapt the CPT for use in the CSRR with ISDS, all 4 categories needed to be reproducible for the CPT to accept incoming ISDS client transmissions and to reformat the prioritized list so that the ISDS shore comm servers will receive the data properly. Next, we'll look at the CPT application program features. The CPT application is started by clicking the CPT application icon. The The CPT was designed to closely resemble the existing ISDS GUI to minimize any additional operator training. TX options, TX modes, the compression mode selections, short site information, TX list views, an operator log, start transmission, cancel transmission, and transmission queue size are all similar to the ISDS TX management GUI. Differences between the ISDS and CPT GUIs consist only of added functionality, that being the tab folders, which separate the ISDS and the ISDS history panels, the addition of training and training history counterparts, a select all checkbox, which allows the operator to select or deselect entire list views, a reprioritize button, which will re-execute the prioritization scheme in the case that the operator had manually moved messages around in the TX list view. On-off buttons are provided so that the CPT may be temporarily shut down without closing the entire application. If there are existing messages stored in the CPT temporary storage, which were a result of ISDS client prior transmissions, they will be displayed in the TX list view, which is started in semi-automatic mode by default. The normal ordering of messages would be first in, first out, as shown here by simply clicking on the field title. Operators can manipulate the TX list in the same manner as the existing ISDS system. This could occur by direct order of the CO. Prioritize list required. MCON mode stands for Emergency Communications. In this mode, no external communications are allowed. Hence, the CPT functions are suspended until MCON is disabled. There are intuitive shortcut menus available within the TX list views. Delete message moves the message to the history tab. Messages that have been delivered successfully will have a status of Reiku, and these items are archived to the history tab via this operation. Set status overrides the existing status and sets it according to the operator's selection. Copy message to training TX queue is an option that allows the operator to load additional messages into the training queue. We will be doing this to simulate the ISDS client sending messages when we investigate the training options. The CPT log provides feedback to the operator during the use of CPT. The ISDS history tab shows all archived messages. As you see here, there has not been any history records added. We could add a few by deleting the message and moving it over to history. As you notice, the CPT log provides some feedback to the operator, and those records are now in the history view. Similar shortcut menus are available on all tabs. We're going to move this message back to the TX list view. The shore site selection is the destination for transmitted Navy messages. Upon setup, you add or modify these sites according to the ship's manual. To demonstrate the CPT in action, we'll use the training mode, which will simulate the CPT functions previously described. As you see, there is no messages in the training TX list view. The Read Queues button will clear the training list view and repopulate it with any current default message records training mode. To simulate messages being populated into CPT, we can select the entire ISDS list, right-click, copy these messages to the training TX view. But first, let's reorder the messages as if they were coming directly from the ISDS, which is first in, first out. Copying messages to the training TX view simulates the ISDS client sending its information to the CPT. Note the CPT log shows activity and provides feedback to the operator. By default, any messages sent from ISDS have a message status of hold. You notice the CPT score here shows that the CPT has prioritized messages according to the scheme. Messages that have unknown date time group subjects size have either come from the top secret queue or the unclassed queue. These messages are encrypted by the KG175 TAC lane, and the CPT cannot read the contents of that TCP message. Therefore, unclassed messages are given the lowest priority, whereas any messages coming from the top secret enclave are given the highest priority by default. In semi-automatic mode, we can manually override the prioritized list, changing it how we wish. You can reprioritize it to the CPT prioritization scheme. You'll notice that the Approve Order of Messages checkbox is not available until a message is selected. Once that occurs, you can approve the messages and then begin transmission. To make it easier, we'll select all. You notice that the message status changes to transmit, and we can begin transmission. There will be a series of pop-up messages that are meant to simulate each step in the transmission process of CPT. First, a connection must be established. CPT rebuilds the conversation header. The shore responds that it received the header successfully. All messages marked for transmit will be sent in bulk through one data stream. And all messages have been sent. Message status changes to Reiku, and the CPT message log provides feedback. In automatic mode, all messages are automatically selected, and all approved messages will begin transmission automatically once a shoreside connection is made. The operator now may select these messages that have been successfully transmitted to the shore and move them to the history list. This concludes the CPT TAP video. Thank you for visiting ASFT booth 508. For a closer look at the CPT, a demo is provided here at booth 508. Just ask one of our ASFT staff. Have a great day.